In this topic, you will learn about introduction to electric field strength, the force between the charges, Coulomb's law, and capacitor. First, what is the Coulomb's law? So what Coulomb's law state? It state, example, if you have two charges, unlike charges or like charges, if they are like charges, they will repel, and if unlike charges are there, they will attract. So if unlike charges, they will move towards each other. So direction of the force is toward the center or towards each other. If they're like charges or identical charges, they will repel each other. So these two particles or charges tend to move away from each other. So this one is a positive, negative, and positive, positive. So what Coulomb state? He states that if two charges are there, if we have identical charges, they will have a force between them. If they are identical, they will repel. And if unlike charges are there, they will attract. So according to Coulomb's, they will apply force on each other. And that force, he suggests, that force is directly proportional to the product of the charges. Example, the charge, the positive charge is Q1, the magnitude of the charge, and magnitude of the charge for negative is Q2. So according to Coulomb's, the force of attraction between them is directly proportional to product of the charge. Means greater the product of the charge, greater the force of attraction or repulsion. And it is inversely proportional to square of the distance between the two, or it follow inverse square law. What does it mean? Like example, R is the distance between the charges. So if we decrease this distance, if the charges are closer, the force will increase. But it follow inverse square law. What is the meaning of inverse square law? Inverse square law means if the distance is double, the force will, if distance is multiplied, force will be divided, but with a square. So square of 2 is 4, so it will be divided by 4. Same thing, if distance is multiplied by 3, so force will decrease, but with what factor? It will decrease by 9. So it vary with a square, and we call that as inverse square law. So according to Coulomb's, the force of attraction or repulsion between the two charges is directly proportional to the product of the charges, and it is inversely proportional to square of the distance between the two. So when we combine these two factors, so we can say force is directly proportional to product of the charge and inversely proportional to square distance between the two. Whenever in mathematical equation we replace the proportionality sign, we replace with equal to and a constant. So we can say F is equals to constant K is equals to Q1, Q2 over R square. What is the value of the K? The value of the K is 9 exponent 9. This is the value of the K. Which is a constant for the equation of proportionality constant. The formula to get the K is 1 over 4 pi epsilon, but in your course outline, you will not discuss this formula. So you don't have to bother about it. Just remember the value of the K is 9 exponent 9. And what it shows that the force between the charges is directly proportional to product of the charge and inversely proportional to square of the distance between the two charges. Is it clear? This is known as a Coulomb's law.
Yes, sir, clear.
Okay, copy the statement for Coulomb's law. In this example, say calculate the force between the 2 point charges. of 100 microcoulomb. So micro means 10 power negative 6. Place 125 centimeter apart in a vacuum. Sorry. So they're placed 125 centimeter apart in a vacuum. Epsilon naught, epsilon naught means permittivity of the free space. Means how much or what is the a number of the field lines which can pass through the space. That is called a permittivity of the free space. Because the value of the K depends on the medium between the charges. Like example, if you have two charges and between the two charges there is a vacuum, and the same charges, the two identical opposite charges but with the same magnitude, but they are placed same distance from each other when there is example a plastic between them. So the force experienced by the two charges in a vacuum will be different from the force experienced by the two same charges, means charges of same magnitude, when there's another material, example a plastic is there. So what is this epsilon naught? Epsilon naught refers to permittivity of the free space, like how much or how many electric field lines the space can allow to pass. That's called a permittivity of the free space. If it can allow more field lines to pass, means the value of the F will be higher. If it allows smaller amount or number of field lines to pass, the value of the force will be smaller. So K is equals to 1 upon 4 pi epsilon. This is a Greek alphabet epsilon, which is having a value of 8.85 exponent minus 12. So in this question, now in this question, first what we have to do, we have to calculate the force between the charges. So how we can calculate the force between the charges? So we have the formula F is equals to K. K is a constant. Either you can find it separately and then substitute in the formula. So we have the formula K Q1 Q2 over R square. And value of the K is equals to 1 upon 4 pi epsilon. And here epsilon is given. So I can substitute 4 pi in epsilon and I will get the value of the K. Then I'll substitute this value of the K in the equation. The charges are 100 microcoulomb. So you can see here. So it's 100 into 10 power minus 6. This 10 is extra. That's so 100. The formula is F is equals to K Q1 Q2 over R square. So you can first find the value of a K, then Q1 is there 100 microcoulomb, Q2 is also 100 microcoulomb, and R is the distance. SI unit of a distance is meter. So you have to convert this into meter. That's why it is written 1.25. And when you substitute all the values, you're getting the final answer as 57.5 Newton. That's a force which the charges will experience. This is not like the force experienced by one. This is the force experienced by each charge. Like example, if two charges were there, if one charge is experienced 57.5 Newton, the other charge will also experience 57.5 Newton. If they are in the same direction, means if they are identical, then they will repel each other. If they are unlike charges or opposite charges, attract each other. So in the question in the beginning, these are the like charges. So like charges will repel each other. But now what they did in the part B, state what difference it would make to the force calculated if one charge is negative. If one of the charge is negative, then what happened? Because in the original question, identical charges were there. Both charges are positive. And we know like charges repel each other, so they tend to move away. But if one of them is positive, another one is negative, so unlike charges, they will attract each other. So what will happen to the force? The force would be attractive rather than repulsive. That's the answer for B1. Then the space between the charges was occupied by air. So what will happen? Because I just give you an example. If you have two identical charges, or you have two different charges with the same magnitude, in the beginning a vacuum is there and now air. So in comparison, because vacuum means nothing is there, so it allows greater number of field lines to pass. But air, the number of the field lines, so the number of the field lines which are passing through the air will be relatively small or slightly smaller than compared to that of a vacuum. So that would be a very small reduction in the size of the force, because the permittivity of air is only or slightly higher than the free space. Because what happened, when you can check the value of the F is equals to K, Q1, Q2 over R square. So what happened if the value of the R decreases, the value of the F will also decrease. And if value of the K decreases, sorry, value of F will also, and K is equals to 1 upon 4 pi epsilon. So if the value of epsilon increases, so value of the K will decrease. As value of the K will decrease, the force between the charges will also decrease. Is it clear? Part B, B2.
Yes.
The
Yes,
space,
sir.
the space was occupied by paraffin, which is having high permittivity. So high permittivity means epsilon. Permittivity of a free space means epsilon. So if value of epsilon increase, value of the K decrease. If value of a K decrease, the value of the force will also decrease. So is it clear? The third part as well. With air, it will reduce but very small amount. But with paraffin, it will reduce greater amount, because higher permittivity means greater epsilon. Greater epsilon means a smaller value of a K. Smaller value of a K means smaller force between the two charges, or weaker force between the two same magnitude charges. Now in this question, this is also related to the electric field. A potential difference of 5.5 kilovolt applied to an electron gun. So what is the purpose of the electron gun? The purpose of the electron gun is to accelerate or provide energy to the electron so that electron can move. In a CRO or cathode ray tube or CRT, in order to accelerate electron from rest, the charge of electron is -1. That's the magnitude of a charge, 1.6 exponent -19. Negative is showing the nature of this charge. The mass of electron is 9.1 exponent -31. Calculate the kinetic energy. So how you can find the kinetic energy? Basically, you provide a voltage or a potential. So electrical energy, what you supplied, like if this was a filament, so we pass the current through a filament, the filament will become hot, and we apply a voltage. So when we apply the voltage, electrons will come out. So what is the energy change here? The basically electrical energy is changes into kinetic. And what is the electrical energy? If you remember the formula for voltage, voltage is energy divided by charge. So electrical energy is voltage multiplied by charge. So electrical energy is voltage multiplied by charge, and kinetic energy is half mv square. So 0.5 mv square. But the question is the kinetic energy of electron as they leave the electron gun. So basically electrical energy converted into kinetic energy. So we'll find the electrical energy and we'll get the kinetic energy. Electrical energy is voltage multiplied by charge. Voltage is 5.5 exponent 3. Why? Because it's 5.5 kilovolts. So that's why this 5.5 exponent 3. And the charge, because electron is accelerated, charge of one electron is 1.6 exponent minus 19. So you'll get 8.8 exponent minus 16 joule. That is the electrical energy supplied to the electron, and that is same as the kinetic energy which this electron will have when it leaves the filament. The next part, you need a speed of this electron. So you already have the kinetic energy. As we know, kinetic energy is half mv square or 0.5 mv square. The kinetic energy is same as the electrical energy, which is 8.8 into 10 to the power minus 16. Then half, the mass is 9.11 exponent minus 31, and you can get the speed, which is about 4.4 exponent 7. So this is the speed at which the electron will leave the cathode ray, the filament of the CRO, cathode CRT. Is it clear?
Yes.
Yes, sir.
Now, how we define electric field? Electric field means what happened when sorry, when there is a charge object, when there is a charge object, so region around the charge object where other charges can experience force, like if you have a positive charge, so the space around this positive charge where the other charges can experience force. Like example, there was an electron here, so that is moving towards. There was a proton, so it tend to move away. So region around the charge where its force can be felt by the other charges, that region is called electric field. But there is a standard definition for the electric field. The definition for electric field, it is a region around the charge where a test positive charge can experience force, that's called electric field. Reason for making a standard definition, so that we have a specific direction for electric field. Example, there is a large positive charge and I place another positive closer to it, a test positive or unit positive, is a very small charge. So which direction this test positive tend to move? It tend to move away. So what we say the direction of the electric field is out from a positive charge. And the lines which represent the direction of the electric field, the lines which shows the direction of the force are refers to electric field lines. Same thing, if we have a negative charge and we place a test positive charge here, small positive. So which direction this test positive charge tend to move? It tend to move towards the negative. So we say the standard definition or direction of electric field line is the direction which shows the force experienced by a test positive charge when it plays in a electric field of another charge. So any charged body generate an electric field. Electric field only act on charged particles. So then we define electric field strength. So what is electric field strength? Electric field strength means it is a force experienced by a unit charge. Like example, we place a positive charge and we place a test charge here. How much force it experience, force experience per unit charge, that is called strength of electric field. Example, this was 1 Coulomb charge and it was experiencing a force of 50 Newton. So what is the electric field strength at this point? Electric field strength means force per unit charge. So it was experiencing a force of 50 Newton and the charge was 1 Coulomb. So it was 50 Newton per Coulomb. So strength at this point, strength of electric field at this point is 50 Newton per Coulomb. Same way, if we bring closer, if I bring this charge closer, if the charges are closer, the distance between them is smaller, so it will experience greater force. As it will experience greater force, so example, now it is 100 Newton. So what is the electric field strength at this point? 100 Newton divided by 1, it will give, you will give 100 Newton per Coulomb. So strength at this point is 100 Newton per Coulomb. So force experienced by a unit charge or force per unit charge at any point in the electric field is known as electric field strength. Is it clear?
Yes, sir.
Yeah.
So how much force experienced by a unit charge simply refers to electric field strength. The formula which we can use to find electric field strength, there are two formulas which can be used. As we know, electric field strength is equals to F divided by Q. So example, if we have two charges, one is large Q, another one is a small q, and they are separated by distance r, and the magnitude of the charge small q and capital Q. So I can apply a Coulomb's law here. I can say F is equals to K Q capital Q small q over r square. And if I substitute this value of the F here, so electric field strength E, in place of F, if I substitute K capital Q small q over r, and then this is 1 over q, so that is 1 over q. Q will cancel with q, so electric field strength is equals to K capital Q over r square. So there are two ways I can find the electric field strength. If I know the source charge, like example, if I know the greater charge and I know I want to find a distance, like at a certain distance I want to find the electric field strength. If I know the charge, I know the distance, so I can use this formula, E is equals to KQ over r square. Or if I know this unit or a test charge and I know the value of the force, so force divided by charge, I can also find the electric field strength. So these are the two formulas which can be used for finding electric field strength. So electric force on a charge in an electric field is known as the electric field strength, and the electric field strength unit is Newton per Coulomb. It is simply defined as a force per unit charge experienced by a test charge at a point. Test charge means a small charge is refers to a test charge or negligible or small value. The direction of the electric field at any point is the direction of the force experienced by the positive charge at that point. So electric field direction is always same as the direction the test positive charge will experience the force. So I want you to copy this part. So how we represent the electric field for if there is a positive charge. So like charges, if you place a small positive charge or test positive charge, because it will repel, so it tend to move away from each other. So direction of the electric field direction is out from positive. And if we place a test positive charge near a negative charge, so it tend to move towards, that's why direction of electric field is towards the positive. The distance between the field lines shows the strength. So here, because the distance is small, so means stronger electric field. As the distance between the field lines is increasing, it shows that it is getting weaker. Copy this as well. And if I want to show a stronger electric field, so I should draw more field lines. Finish done.
So just the last line. So done.
So this is a small derivation which involves like if there's a point charge that is a body with charge but negligible size, or so if you have, for example, a large big charge and a point charge, and the value is q and small q for a point or a test charge, and the distance between them is r. R is distance between them. So as we know, according to Coulombs law, the force between them is equals to k small charge kept product of the charge and square of distance between them. And we also know, according to the electric field strength formula, E is equals to F over Q. So F is equals to E multiplied by Q. So in place of this F, I can write EQ. So this Q will cancel with Q. So what we can say? We can say E is equals to K capital Q over R square. So if I know the value of the bigger charge, and I know, or I want to find at any specific distance the strength of electric field, that's R. So I can use this formula for a point charge Q. Is it clear? And this is like, this charge is a point charge as well, like that negligible. It is having a charge, but its mass, its size is negligible. Is it clear? So we can
Yes.
use this, we can use, like example, if the electron is there, electron can be considered as a point charge because size of electron is negligible as compared to any other charges. So if I want to find a strength of electric field due to this electron at a distance of 2 meters away. So if I want to find the strength of electric field at a distance of 2 meters away, so what I can use, I have the charge of electron, I have the distance, and I have the value of the K. So I can find its electric field strength. Is it clear?
Yes, sir.
So just copy the last formula. It's point charge, electric field of point, types of electric field. First is the electric field of a point charge that's given by E is equals to KQ over R square. This session will end less than a minute, so I'll share another link.